Now this one has a thousand different names. At least it feels that way sometimes. They're all talking about the same thing though. So formula mass is what the Trode textbook refers to it as. I usually am going to be referring to it as molecular mass or molecular weight, just by habit. But all three of these things are absolutely interchangeable as far as they go. Now, what are they? I'm glad you asked. It's the mass of 1 mole of the molecule. So if I take a whole mole of sugar molecules, that'll be the mass of 1 mole of sugar molecules. Of course, I'd have to specify what kind of sugar, but we'll leave that for later. Now what we're going to do is we're going to add up the mass of all the atoms that are inside of it. So that probably makes some sense. I mean, if I have 3 carbon atoms, well then I need to add up the mass of all 3 carbon atoms. Then the hydrogens that are around it, I need to add those up too. And that's the basic approach that we're going to use. So here's where we're going to have a bit of an example to solve out. If you'd like to pause and give it a try, go for it. This isn't one where I'll have you solve it as a problem video. I'm actually going to work through it right now. But if you want to try things out first, go ahead and pause and give it a shot. Now here's how I like to set them up. I'll write all of the different atoms that are in there just down a little column. And I'll put their molar masses. Instead of having to Alt-tab back and forth between a periodic table and this window, I just went ahead and wrote them down in advance. So we have the mass of carbon, hydrogen, nitrogen, and sulfur. Notice at the moment they're all for sig figs, but we're about to do the addition-subtraction rule, so that doesn't matter much. We'll see that in play in just a moment. So now that I've got my masses, I'll multiply by how many of each atom I've got. I have 5 carbons. I have 10 hydrogens. I've got 1 nitrogen. Remember, we don't need to write the number if we don't have any more than just 1. And sulfur, I've got 2 of those. So now what I need to do is multiply across these, and then I'll know how much mass I have for each atom. Okay, so we have 12.01 times 5. That's going to give me 60.05. Now I do recommend that you write this down and not just chain them in your calculator, and we're going to see why in just a moment. Okay, so then we do our, now that one's going to be easy. I'll just write that one in a second. That one's also going to be very easy, so let's just do this bottom one. So it's 32.07, oops, 32.07 times 2, there we are, 64.14, 64.14. This one is very easy because we're multiplying it by the number 1. This one's easy because we're sliding it 1 decimal place. This is an exact number. All of these are exact numbers. No impact on sig figs. So we'll just bring this over and we'll slide our decimal point. So it's 10.08. Now, if we hadn't had to multiply by 10, notice that we would have had it 3 decimal places hanging off the edge. And so we would have ended up chopping off one of those at the very end. We didn't have to do that in this case because when we multiplied by 10, it moved over 1 place. Now it's time to add these back together. Okay, so we're going to have our, let's see, 60.05 plus 10.08 plus 14.01 plus 64.14. That gives us the answer 148.28. So 148.28. Now, sig figs. If you're about to go ahead and chop this off and round it to 148.3, you're using the wrong rule. Remember, multiplication and division, we go for the fewest number of sig figs. That's not what we just did. We did addition, subtraction. Addition, subtraction, line it up at the decimal point. You chop it off after the shortest place. In this case, we've actually increased things to be 5 sig figs. So it'll be 148.28 grams per mole. We always got to get our units on there. I go ahead and get, oops, didn't mean to get rid of that part, but all right. And there we have it. So we've done our calculation for this one.